It's easy and secure. Thank you.
In 2015, the Wyoming legislature appropriated funds to promote a transition from a research-based cloud seeding trials to operational cloud seeding projects. Wyoming Chronicle travels to an operational ground-based cloud seeding site in the Wind River Range to learn the history and the expectations of weather modification in Wyoming. Next on Wyoming Chronicle.
Funding for this program was provided in part by the Wyoming Public Television Endowment and viewers like you.
My name is Michael Paul. I work for Weather Modification Incorporated, and this here is one of our ground seeding generators in the Wind River Range in Wyoming. Basically just going to walk you through sort of how it operates and how it works. So we run these remotely, and we have a satellite modem at the top that gets our signal. It has a computer box that will turn on the generator, which will have the propane tank that will turn on our burner. And from there, it will heat up. A temp sensor will come on and tell our solution tank, which is right there full of our seeding agent, to pressurize the system, and it will release the agent into the atmosphere. Our nitrogen tank that pressurizes the solution system so that we can get it up to the 25 feet where our tower's at. We have it up there so that the wind can carry our plume to the target range, which is the Wind Rivers, which are behind us over here. A little windier up there. So it's a pretty straightforward system, really. The solar panel charges 4 batteries in our battery pack there, and I can power the system for all winter long. So I think we'll go ahead and get it turned on here. So right now the propane flame is coming on, and it's heating up the system. And then once it heats up, it'll turn the solution tank on, and it'll push the solution out, and you'll see a bigger flame coming out.
And our thanks to Michael Paul from WMI for showing us how this weather modification apparatus works. And we're pleased now to be joined by Jenny Cederle, who's a project manager for the Wyoming Water Development Office, and Barry Lawrence, the office's deputy director. Welcome to Wyoming Chronicle.
Thank you.
Let's start with the history of weather modification. Barry, and let me begin with you. This is a technology that has evolved over the last 60 or 70 years.
That is correct. And in the state of Wyoming, actually, weather modification has gone on since the early 50s, where individual proponents would come to the state engineer's office, ask for a renewable permit every year to do various weather modification activities across the state in various different areas. The longest running program in the state of Wyoming, however, without a doubt, is the Eden Valley Irrigation District out of Farson, who've been running their program targeting the Big Sandy Draw and the Wind River Range. And that's been running since the 70s, where they started a program. It was basically a turnkey system given to Eden Valley Irrigation District, working with the University of Wyoming.
So what have we learned? How has this technology evolved? How do we know it works? Jenny, what do we know about cloud seeding?
What do we know about cloud seeding? Well, we're very confident that the technology behind cloud seeding is successful. There was a research project. Wyoming legislature funded a research project that started in 2005 and ran to about 2014, so almost 10 years long. The research-based weather modification, the Wyoming Weather Modification Pilot Program, and it did provide us the background to let us know that cloud seeding is technically viable for the state of Wyoming. It was a ground-based seeding program that targeted the Medicine Bow Sierra Madre Mountains and the Wind River Range.
We're here in the middle of summertime, but in Wyoming, this is a winter project. When does it begin?
Well, the program typically begins early November, mid-November, and will run typically into April. And this isn't a project that just runs all winter long. There are certain atmospheric conditions that allow the project to function. Talk about those, Jenny.
Certainly. So when we start looking for suitable clouds or suitable conditions for cloud seeding in the Wind River Range, really we need the presence of clouds with supercooled liquid water. That's one of the first things that we need. From there, you have to start looking at the temperature of the cloud, anywhere from -5 to -6 degrees Celsius. I believe that's -23 degrees Fahrenheit.
Plus 23
Plus
degrees.
20, thank you. Plus 23 degrees Fahrenheit. And when it depends on which type of a program you're running. In the Wind River Range, we're running 10 ground-based generators. So what's a really important factor there is wind speed and wind direction. Because once, as Michael showed you, that the plume is atomized in the propane flame, and we have this non-visible, vapor that goes up, it's the wind speed and the wind direction that carries it over the barrier and into the cloud where the supercooled liquid is present, and then that interacts with the ice nuclei that was in the vapor and can create snow.
Now, supercooled liquid is water that is below 32 degrees but not yet frozen.
Yeah, people are pretty shocked sometimes when you find out that liquid can still, or water can still be in liquid form below the freezing level, but that's what happens.
So why silver iodide? Why does that work? Can you give us a little bit of a science lesson here?
Oh gosh, I don't know. Okay, so the silver iodide is, it attracts the water once it's in cloud, and what it does is it's crystalline features. It's six-sided, very similar to that of snowflakes, and so it's very conducive to forming snow.
And these are projects that aren't unique to Wyoming. Many other states also utilize this technology. That is very correct, and probably one of the biggest eye-openers is finding out how much of this is going on around the state of Wyoming. You might be surprised to know that a lot of the western states, Colorado, Utah, Idaho, even in California, there's cloud seeding going on. And what do we know about the end product? How do we know that it works, and to what extent does cloud seeding work? Okay. Well, obviously, one of the reasons that we embarked on the large research project was to look at that. Does it make sense for Wyoming? What is the difference we're going to be making? What is additional water we're going to get in the system? Because ultimately, it's about the water and the stakeholders. So Wyoming embarked on a large 10-year research project to come up with that. What are the increases? And it was based on physical and statistical evidence and so forth, looking at layers of evidence to come up with the additional amount of snowpack one might receive. But then not only just stopping at the snowpack, where a lot of programs do, taking it to another link in the chain to actually look at the hydrology. Well, if you get a 10% increase in snowpack, what does that mean to additional water in the system? Because ultimately it is about the water and the stakeholders. And what percentages are we talking about? General research, I think that I've read, says between 5 and 15% increase in precipitation from any given storm. Is that accurate? That is correct. That is what our study found. And does that hold in all of Wyoming? Does it work in some areas or not in others, or is that all about atmospheric conditions? Obviously, it's about atmospheric conditions, but obviously it's about the barrier that you're working with. The Medbo Sierra Madres, for instance, program is totally different than the Wind River Range. You've got a much more pronounced barrier in the Wind River Range. You don't have all the foothills and so forth. So that program was designed differently. Now, we're in the southernmost generator in the Wind River Range, but there are 10 in the system. How is the placement of these generators? How is that decided? What's the science behind that? I can tell you that when they placed the generators in the Wind River Range, a lot of thought went into it. Scientists at the National Center for Atmospheric Research actually did trajectory modeling. They did back trajectory modeling with a ski puff model, and they looked to see, well, where was that parcel of air 20 to 30 minutes before it hit the mountain range? Where did it originate from? And so from there, they could do their siting of their generators. So these are all strategically placed. How do we know that it's safe? Many of our viewers have to be wondering, is modification of weather, number one, needed at all? But number two, is it safe? How do we know that injecting silver iodide into the atmosphere is safe? Well, I can tell you there's been numerous studies that have looked at this, and I can tell you in all cases that it's just not an issue. We, in the Wyoming project, obviously when we embarked on the operations, one of the things that folks were interested in, well, we needed to look at. We needed to do due diligence. We needed to look at, is there an environmental issue here? So we did background monitoring of the silver before we began seeding, and then throughout the program, before seeding events events, after seeding events, and so forth. And what the scientists and the folks that conducted this were the Desert Research Institute out of Reno, Nevada, which are very good at what they do. They came out in their clean suits, collected the snow, did the snow chemistry sampling, and what they were finding were levels of silver 5 to 10 parts per trillion, which would be lower than, you'd have to have magnitudes of order greater to be any risk.
Is silver iodine the only technology that different systems use to enhance precipitation recovery with cloud seeding programs?
There are other ways of doing that. Some programs obviously use propane generators and so forth. Actually, they're propane units that would be placed higher up on a mountaintop, and through release of propane into a cloud, you'd have to be in cloud, but it actually starts the freezing process.
There's other summertime programs that use dry ice that absorb the water and attract it to it. They're more for rain enhancement programs, but dry ice is another mechanism.
Are there summer programs that operate in Wyoming?
No, not at this time.
All our winter programs. Jenny, earlier this summer, you were at a public meeting in Saratoga where the results of a study relative to the Sierra Madre and Medicine Bow mountain ranges, that information was released to the public. What did we learn, and how is that project coming along?
Well, that study, that public hearing, presented the results of a final design and permitting study that had gone on, started in 2015. And the results of that study, what we were aiming to do was develop an operational program in the Medicine Bow Sierra Madre Range that was based off of the results of the 10-year research project. So that kind of fed and rolled into this study. What we're seeing right now is that for the Medicine Bow Sierra Madre ranges, an aircraft seeding program may be the most cost beneficial for us. No decisions have been made how we're going to proceed, but we did take a look at building a robust generator network out there, did some modeling, figured out what the impacts were, what maybe our seeding effect was, which actually came into line with the results of the pilot study, the research program. But just based on cost alone, we might be taking a look at trying to build an airborne seeding program in the Mid-Bow Sierra Madres.
I thought it was interesting in that public hearing, the discussion of how computer modeling was applied to this program, that the NCAR supercomputer that sits near Laramie and Cheyenne was used in the modeling and forecasting of how this program could work. What did you learn about its use?
Well, what's exciting for me is coming in, I'm fairly new to the project. Barry was the beginning of the research project, and he carried it all the way through to the end, and then I kind of stepped in as the state transitioned from research-based weather modification studies to try and really get, as Barry has taught me, boots on the ground, more operational. And a piece of that study that you're referring to with the supercomputer modeling, it was really interesting because NCAR designed a new approach. And earlier in this interview, you were talking about how the technology has gone forward from when we started the research project to where we are now. And it truly has gone leaps and bounds forward. So the type of modeling that was done is referred to as ensemble modeling, where they take several different cases from that research program and they run hundreds of runs just to take simulations, which helps reduce the uncertainty of the results. So what we're taking away from that is we had some numbers, some seeding effectiveness numbers, 5 to 15% per seedable storm over a certain percentage of area back 10 years ago. Move future forward with newer technology and you refine it, but it still is within that realm. So we know that we're really close to a true answer.
Using maybe less resources, less silver iodine, to create the same results in a more exact way?
I couldn't speak to that because that really depends on what your final design is, how many generators you opt to use, 1 range, 2 ranges. Each range is kind of unique in what the final design setup would be.
I thought it was interesting in researching this program that Wyoming isn't the only benefactor of Wyoming's cloud seeding programs. Barry, there are other states that are highly interested in our ability to enhance water supplies, especially those that end up in the Colorado River.
That is correct. And over the past decade, while Wyoming's embarked on this, a lot of eyes have been on Wyoming and the inquiries and so forth from other water agencies, other states, so forth on what Wyoming's done, because the state has a lot to be proud of here and pushing the science forward. And I really believe we have pushed the science forward, allowing folks such as Idaho Power to build on what we've done in the western Wyoming and in their own operations in Idaho and so forth. So there is a lot of interest in what we've done, but in the Colorado River Basin, of which you mentioned, there's a acute interest. Obviously, the issues in the Colorado River Basin, the shortages of water and so forth, down the system and so forth, and so much so that they've been willing to invest in the Wyoming program. And when I say lower basin, I'm talking about folks such as some of the lower basin entities, the water purveyors in the states of Arizona, Nevada, California, and so forth, interested in the Wyoming program.
Not only they are interested, they're helping pay for that.
That is correct.
How are they doing that?
Basically, the way it's set up, annually we go through agreements with those entities, and right now it's set up as a cost share where we pay 25% of the cost, and those lower basin folks are paying 75% of the cost operating here in the Wind River Range.
Barry, there must be some thought given to the economic value of additional water, 5 to 15% in a water basin. What is that value? Have we looked at assigning, you know what, this is really generating X amount of dollars worth of water, not only for Wyoming, but those downstream?
And that's key. I mean, does it make sense for Wyoming to continue in this? And to look at that, as I mentioned earlier, we didn't want to stop at increase in precipitation. We wanted to go to the next link in the chain. Actually, what additional water does that mean in the system? Because ultimately it is about the water in the system for the stakeholders. And so to that end, we did a lot of hydrologic modeling and so forth, taking that 5, 10, 15% regime in the Medbos, Sierra Madres, and then routing it through the system to see how many additional acre foot of water we're going to get by doing that. And then obviously, if you know the cost of your program, then you can figure out dollars per acre foot. And when that was done, low end is in the $30 to $35 range, high end up to $100 per acre foot, but somewhere in there, depending on the effectiveness of the program and how much of the range you're targeting.
So are there thoughts that other mountain ranges in Wyoming might be an applicable place, if you will, for water seeding programs? Or have we looked at the mountain ranges where this is going to work the best?
Well, we've certainly, the legislature has asked us to look at other mountain ranges. So most recently, along with the Medbos and Sierra Madres, looking at transitioning to operational. We've looked at the Laramie Range now. We've also looked at the Bighorn Range, which Jenny managed those programs. We've also looked at the Wyoming Range, in addition to what we've done here in the Wind River Range.
Is there pushback that either your office gets or that you hear of indirectly through the legislature that people that have concerns about this program? Is it a matter of education? What do you hear, and what are the major objections, if there are any?
Certainly, we do receive, from time to time, inquiries and so forth, and we're happy to respond to those inquiries. One of the best things we can do, obviously, is public outreach and education. I think because if the folks out there get learned about it, they're much more, intimidated by it or worry about the program. And really, education outreach is the key to this from the beginning of the project throughout. And you just never can stop telling the story. And we really believe that. I think once people understand what we're doing and what we're not doing, then there's a level of comfort with the program.
Is there research out there that does cause pause for you or for others that are operating programs similar, to your knowledge?
I'm not aware of any such research, no.
I thought it was interesting, too, that there are conditions or times when you'll shut the system down if certain water goals or precipitation goals have been reached. And in fact, that happened at this very site just this last winter. How do you monitor how long the system should run and when you've caused enough?
A really important part of any operational cloud seeding program is the development of suspension criteria. And for the Wind River Range, the suspension criteria that we used that ended up suspending the program pretty early on was an estimate, an average look at 5 SNOTEL sites around the region. So not only do we have 10 generators set up in the range, but we also use 5 SNOTEL NRCS SNOTELs to help us gauge snowpack as we go through the season, or SWE, the snow water equivalent, as we move through the season. And we have a certain threshold set at 140% of the April 1 amount. And as of February 10th, we were at that amount. We had broken that threshold, looking at all 5 of the SNOTEL sites. So we immediately suspended operations, hoping that we would actually be able to come back online before the season was season's over. This season was ending, scheduled to end March 31st, but Mother Nature beat us to the punch, and we had, excessive snowfall amounts in the range, and so we were never able to resume the cloud seeding program this past winter.
Those of us who live in Fremont County credit you with all the shoveling that we did.
I know, they tend to do that.
Last winter too, but certainly Mother Nature has a great majority to play. But one wonders if this is a matter of robbing Peter to pay Paul. In other words, downrange, what does your research say? Well, geez, if you're really increasing precipitation here in Wyoming, then what aren't you allowing to have happen downrange? And what have you learned about what cloud seeding does to someone who might live in Nebraska or Iowa or somewhere east?
So that's a common concern that we hear a lot as we move throughout the state doing our outreach and education. And I think a really easy way to try and describe that for the general public is that whether or not we're cloud seeding in the range, it's not linked to whether or not a storm is going to precipitate downwind of that mountain range. So it's really the natural, the Earth's natural water cycle, the process of condensation, evaporation, condensation, and precipitation. It continues downrange, downwind of the mountain range, whether or not it has precipitated out on top of the mountain range. And the amount of water vapor that any storm moving up and over a mountain range uses is negligible compared to the overall water budget.
As it was reported, at least in the Sierra Madre study, I think that number was 1%.
Exactly, 1%. And it's really interesting, too, to start comparing the barrier precipitation storms versus the plains because of that ongoing evaporation, condensation, precipitation. Generally, any storm that's orographic in nature, you use the vertical lift to build that and to snow out over the top or across the leeward side. But generally, your air parcel is warming as it goes down and drying out anyway. So it would rely on the natural cycle to rebuild.
Well, Jenny Cederle and Barry Lawrence, it's been a pleasure to visit with you on Wyoming Chronicle. We want a chance to visit with your director, Harry Labonte. So thank you for joining us.
Thank you very much.
And we'll be right back to visit with the director of the Wyoming Water Development Office, Harry Labonte. Stay tuned. Harry Labonte now joins us. Harry is the director of the Wyoming Water Development Office. Welcome, Harry. Good afternoon. Back to Wyoming Chronicle. Harry, we're at the Anderson Ridge site where we've been shooting all day. Why are these water modification projects so important to Wyoming from your perspective?
Well, if you look at the mission of the Water Development Commission and the Water Development Office, it's to develop water resources for the benefit of the citizens of Wyoming. And we do that through the traditional sense where we build water infrastructure projects, whether it's dams and reservoirs or water transmission or supply projects. But also, because it is an arid climate, there's an opportunity to enhance or increase the water supply through weather modification. And that's why water development is interested in that and why we've been working through research projects and now moving into the operational phase. It's to provide more water ultimately for the water users in Wyoming. And I would add that there is a secondary benefit to all of our downriver or downstream states because Wyoming gets to use the water first, but there is also additional water then flowing to our neighboring states.
Harry, you've had support from the legislature for these projects. Is that a challenge now that you now face with Wyoming dwindling resources to continue either research or operational sites like this?
Yeah, I feel we've really